This is Unit 4, Lesson 13, Solving Systems of Equations, and this is a matching activity. You have three systems of equations that are graphed, and you have the equations for those three systems, and you're supposed to match them. The first thing is look at the slopes for each of these graphs. This is a positive slope, and this is a negative slope. A positive slope, a positive slope, a positive slope, and a positive slope. And down here for the equations, only one set has a positive slope and a negative slope, and that's A. So this A right here has to match this A up here because the other two have a positive slope and a positive slope, and a positive slope and a positive slope. So this one matches A. And further, you can see that it matches A because this y-intercept is 5, this y-intercept right here is 5, this y-intercept is 20, and this y-intercept for the other graph up here is 20. So A matches A. And the slope for this equation is a positive 3. So that means that for every unit along the x-axis, you're going to go up 3 units along the y-axis. So if I choose to go over 5 units along the x-axis, then I have to go up 3 times 5, or 15 units along the y-axis. And so this point lands on the line, and this also has a y-intercept of 5. For this equation, the slope is negative 2, which means for every unit along the x-axis, I have to go down 2 units. So once again, if I choose to go 5 units along the x-axis, then 5 times 2 is 10, and 5 times a negative 2 is a negative 10. So I have to go down here, negative 10 units, and I land on this line once again. And this y-intercept is 20. So if we find the difference in the y-intercepts and the difference in the slopes, and divide, that's going to tell us how many units we go along the x-axis till we reach this intersection. Because what's happening is the difference in the y-intercept means that we have to close this gap by 15 units. 20 minus 5 is 15. And every unit along the x-axis, we close this gap 5 units, which is the difference in the slopes. So how many times can we take that 5 units out of 15 units? That's that 15 divided by 5 equals 3 times. So x equals 3. At this point, y has the same value for both graphs, and y has the same value for both equations. So this y is equal to this y. So using the transitive property, we can now set these two expressions equal to each other because they will also have the same value of x at this point. So 3x plus 5 is equal to negative 2x plus 20 at this point right here. So now we can solve for x and figure out what the x value is at that point. So the first step, here's the 20 minus 5, and here's this 20 minus this 5. Gets rid of the 5 on the left side of the equation. So you're left with 3x is equal to negative 2x plus 15. 20 minus 5 is 15. And 3 minus a negative 2, that's this 3x right here, minus this negative 2x right here. That gives you an answer of 5x on the left side, gets rid of this negative 2x on the right side, and you're left with 5x equals 15. So this is the difference in the y-intercept. This is the difference in the slopes. And so now you're going to divide. 15 divided by 5 is going to tell you how many times you can take 5 out of 15, and that's going to be the value of x. So x is equal to 3. Now if x equals 3, you can use either of these equations to figure out what y is at this point, because both graphs go through the same point, so you can use either equation. So this equation, 3 times 3 is 9, 9 plus 5 is 14, and the second equation, negative 2 times 3 is negative 6. 20 plus negative 6 is also 14. So this point is the solution to the system of equations because that is the only point in which x will have the same value, 3 in this case, and y will have the same value, 14 in this case, for both graphs and both equations. The system of equations that matches these two graphs are either this system right here or this system right here. And this graph has a y-intercept of around 12, and this equation has a y-intercept of 12. This equation has a y-intercept of 27, and this equation has a y-intercept of 27. These two y-intercepts are negative. This is a -1, so down here somewhere, and this one would be a -10, so it would be right there. So the system of equations that matches these two graphs has to be C. And you can check that by looking at the slope. So this slope for this equation right here is 1/2, meaning the length along the y-axis is about 1/2 the length along the x-axis. So if we choose 5 units along the x-axis right here, then this is going to be half that length. This length along the y-axis is going to be half that length, which is 2.5, and that is about 2.5 units right there. And this slope is 2, which means the length along the y-axis is going to be 2 times the length along the x-axis. So if we choose these same 5 units, then that means that this length along the y-axis for this equation has to be 10 units, twice as long. And so this goes from about 7 to about 17 or 10 units. So the slopes match and the y-intercepts match. So the system of equations C matches these two graphs. The difference in the y-intercepts is 27 minus 12 is 15 units, so this is 15 units between these 2 points, and the difference in the slopes is a -1.5 units. That is this 5/10 minus 2. And so to close this gap, every unit along the x-axis is going to make these two graphs 1 5/10 units closer. So how many of those -1 5/10 can you take out of 15? That's 15 divided by a -1 5/10 equals a -10 times. So the x-coordinate right here is going to be -10. And so the y-coordinate is going to be the same for both equations. You choose -10 for this equation, you're going to get the same y-coordinate as when you choose -10 for this equation. That makes these two y-coordinates equal to each other, which means you can set these two expressions equal to each other using the transitive property. And so now we can solve for this value of x, and we already know that it should be -10. So this is the difference in the y-intercepts. So this 27 minus this 12 right here gets rid of the 12 on the left side. You end up with 15 units. And the difference in the slopes is a -1.5 units. So this 5/10 right here minus this 2x is going to equal a -1.5x. And you can take that -1.5 out of 15 units, these 15 units right here, 10 times. So it's a -10. So the x-coordinate will be a -10. And so you can use that value to figure out what the y-coordinate is. So you can use either equation because both equations, x is -10 and y is going to have the same coordinates. That intersection right here, that point right there. So it looks like it will be somewhere close to 7. So this is -10. And you go to the intersection, it looks like the intersection should be moved over just a tiny bit, and you're going to end up at 7. Replace this x with -10. Half of -10 is -5. 12 plus -5, or 12 minus 5, is that 7. Use the other equation. 2 times -10 is -20. -20 plus 27 is 7, or 27 minus 20 is 7. So this point right here, the solution to the system of equations is -10, 7. So at this point, when you use x equals -10, you will get the same y-coordinate, which is 7. So that's the solution to the system of equations. That's the intersection of the graphs. For the graphs in figure C, the only system of equations that's left is this system right here. So this system has to match these graphs. And the y-intercept for this equation is -10. So that's -10 right here. The slope right here is 2, so that means that the length along the y-axis has to be 2 times the length along the x-axis. So if we choose 5 units for x, that means the length along the y-axis has to be 10, which it is. And the y-intercept for this equation is -1. So that's right here. And this slope is 4, which means that the length along the y-axis has to be 4 times the length along the x-axis. So if we choose those 5 units once again, 4 times 5 is 20. So this point right here matches, it's on the graph. So if we look at the difference in the y-intercepts, so -10 minus -1. So this -10 right here minus this -1 right here, that equals -9. So this is -9 units between these 2 points. And the difference in the slopes is this 4 minus that 2. So 4 minus 2 is 2. So every unit along the x-axis is going to make these two graphs 4.5 units closer. So -9 divided by 2. How many times can you take out those 2 units? You can take them out 4.5 times. So this x-coordinate is going to be a -4.5. So -9 divided by 2. You're going to take out 2 units each time. How many times can you do that? You can do that 4.5 times, but it's a -4.5. So at this point, the x-coordinates are the same. And we know it's a -4.5, but we're going to figure that out. We're going to confirm that. But that means because the x-coordinates are the same at this point, and the y-coordinates are also the same. So that means you can set these two expressions equal to each other using the transitive property. If the y-coordinates are the same, that means that these two expressions are the same. And the mathematical language is that you can replace or you can substitute this y value with this expression. So you make that substitution and you can write this equation up here. So now to solve for this x-coordinate right here, you can find the difference in the y-intercepts, which is this -10 minus this -1. So I'm skipping some steps here. This is -10 minus -1. That equals that -9 right there. And this 4x minus this 2x is equal to this 2x right here. So 4 minus 2 is equal to 2. And then to solve for the x-coordinate, that's that -9 divided by 2. So how many times can you take 2 out of -9? The answer is a -4.5 times. So this is the x-coordinate. And now to figure out what the y-coordinate is at this point, because they're the same, it's the same value, you can use either of these two equations. So if x is -4.5, 2 times -4.5 is -9, and -9 plus -10 is -19. So this coordinate right here, the y-coordinate, is -19. If you use the other equation, 4 times a -4.5 is a -18. And a -18 plus -1 is -19. So again, this coordinate right here is a -4.5, -19. It's the solution to the system of equations. It's where the same x-coordinate gives you the same y-coordinate.